Hello everyone. In this video we are going to build a machine learning model with Python that's going to predict whether someone has diabetes or he doesn't have. And we are going to use one of the most important algorithms in machine learning, which is the support vector machine, or we can call it the support vector machine classifier. So let's understand how does this algorithm work and when we use it. The support vector machine classifier, we use it when we want to build a machine like a classification model or for classification projects. What do we mean by that? When you want to predict one of two things, we call the classification. Like you want to figure out if someone has diabetes or he doesn't have, one of two things. Or you want to see if the thing is a dog or a cat or pizza or a hot dog, one of two things, that's it. So first we are going to feed our data to the algorithm. The algorithm will learn and we will have a trained model or a trained algorithm based on the past data. So when we bring a new information or a new data of people and put it inside the trained model, it will figure out if this guy or the person has diabetes or not, based on the past information, and of course with a certain accuracy rate. So that's it. Now let's understand the workflow to build a machine learning model, the whole steps. These are the fundamental steps or process for building any machine learning model. So you need to memorize this well. First, we need the data sets. We can bring it from different online resources, or we can bring it from the website, Kaggle. I will put the link below. And first thing, we need a data set. Then we are going to process our data, pre-process our data, clean it, and prepare it. After that, we are going to split our data into training and testing sets. Then we are going to feed it to the algorithm, the support vector machine. After that, we are going to have a trained model. After we having a trained model, we can put our new data to figure out if someone has diabetes or not. So these steps are constant for all models of machine learning. But of course, with different projects, you are going to have a new data set, and maybe you want to choose a different algorithm for different project. But these steps are the fundamental ones, and you need to memorize them well. We are going to use Google Colab to code out our project. So here in Google Colab, as you can see here, you can change the name of your project as you like. Just click on this and change the name as you need. And let's do the first step. First step in building our project, we need to import the libraries or importing the dependencies for our project. So let's write it down. Import the dependencies. Then let's import them. First one is import NumPy as NP. Import pandas if we need it as PD. Then from scikit-learn, from sklearn dot pre-processing import let's import here standard scalar. From sklearn dot model selection, import train test split. And from scikit-learn, let's import the algorithm now. From sklearn import support vector machine. And from scikit-learn, from sklearn dot matrix import accuracy score. Alright, that's all we need now. And we will explain why we need each one of those when we get to them. Let's click Shift and Enter, and here we go. Now we need to collect the data for our project. I have found diabetes data sets online, and you can download it by just click on download from here. I will put the link for you in the description. I already downloaded it, so let's try to upload it to our Cola file. From here you can click on here files, then right click to load it, this one, diabetes, and we need to load it to our Panda data frame. Just click on code and let's create a variable for our dataset. Let's say just dataset. Then pandas pd dot read underscore csv, and between these quotation marks you are going to put the dataset full name, diabetes.csv. and enter, shift and enter. Okay, so your data now is loaded to your data frame. So now we can start cleaning and preparing our data. Now let's go ahead and check our data. So click on code and dataset.head. Enter. This is going to show us the 5 first columns of our dataset and the titles, all of the titles here, the head titles. So as you can see here, you will need this to check if there is like missing information or some like disarrangement or anything. Anyway, there's nothing. We can build our model already. So let's go ahead and split our data into training and testing sets. It's like this: X train, X test, Y train, and Y test. All right, equals train, test, split, X, Y. And now let's put amount of data should be tested and amount of data should be training. We will put the test size will be 0.2, so 20%, and the testing will be 20%, and the training will be 80%. And let's put the random state as 42 as recommended. All right, that's very good. We split our data now to training and testing sets. After that, we need to build our model, the algorithm. So we'll use it, support vector machine model equals. Now we need to import the support vector classifier from the support vector machine. Let's go to the import here. Oh, I already imported it. You need to write this line of code from scikit-learn.support vector machine import the support vector classifier. I already did it. So let's go ahead and finish our algorithm. Support vector classifier, and here kernel equals linear. Let's check it now. All right, this is our model, but now we need to train our model. So support vector machine model, we need to train it. So click dot fit and X train, Y train, and shift and enter. Now our model is training, executing here, as you can see. Very good. Our model has been trained. Now we have a trained model. So now let's go ahead and make a prediction with our model, our trained model. Click on code, and let's make a variable. Let's call it prediction. All right, SVM model dot predict xtest. Oops. Shift enter. All right, very good. The prediction is done. Now let's make another variable for the accuracy to check the accuracy of the model. Accuracy equals accuracy rate, accuracy score, I mean, y-test and prediction. Very good. Now let's print the accuracy to check it. Oops. Very good, beautiful. Now we have accuracy score of 0.75. It's equal to 75%. It's very good, but not excellent, because we can get even higher accuracy rate, even for like it can reach to 95%. It all depends on the data. The large amount of data, the better, and also how how good the data is. Anyway, this is all. Hope to see you on different projects. Thank you all.